Hi guys, this is David Bell with DOK III Tutors. I'm here to talk to you about a lesson that I want to do tonight for you to watch, just so you can see what tutoring out of the convenience of your own home would be like. So tonight I'm going to present a lesson to one of my students. It's going to be a math lesson and we're going to talk about the Pythagorean Theorem. So I hope you will enjoy what we're going to present.
Hi Rachel.
Hi Professor Bell.
How are you doing tonight?
I'm good, how are you?
Doing well. Are you ready to continue with math?
Yes, I'm very ready.
All right. Do you remember what we went over last time?
Yeah, briefly. Could you refresh me?
I can. I'll give you a hint. Can you see the screen?
Yes.
And?
Powers and square roots.
We did. We went over powers and square roots. What do you remember about powers?
I remember that that they have exponents, and that is very important when figuring out what the solution is.
Okay. Yeah. Here, now let me just write something for you.
Okay.
5 to the second power. What's that equal to?
That is 5 times 5, which is 25.
Okay, very good. 5 times 5 equals 25. Now what if I said, what is 5 to the third power? What was that? What was that?
That is 5 times 5 times 5.
Good. Now you have to remember that exponents are repeated multiplication.
Right.
Unlike, a lot of people will say this is 5 times 3. Well, it's not 5 times 3. 5 times 3 is
15.
It's repeated addition. It's like saying that I'm going to take 5 plus 5
Right.
plus 5, which equals, as you know, 15. So multiplication is a lot different than an exponent. Exponents are repeated multiplication. Multiplication is repeated addition.
That makes a lot of sense.
All right, cool. So what if I said, like, what is 5 to the fourth power?
That would be 5 times 5 times 5.
Very good. And it's going to be a large number, so.
I'm sorry, 5 times 5 times 5 times.
Yeah.
4 times.
We don't even need to figure out what it is. Okay? All right. So that's good. I'm glad you remember about powers. Powers are also called exponents. It can be to the second power. That's how we say it, to the second power, to the third power, to the fourth power. But there are exponents as well. And in our order of operations, we do parentheses first, exponents after that, multiplication, division, then addition and subtraction. Okay? All right, now what about square root? What do you remember from square root?
I remember that square roots are super important in the math world.
Right, okay, good.
I think, aren't they kind of the opposite of,
Good observation.
the opposite?
Yeah, like 5 to the second power could be the opposite of the square root of 25.
Right.
So if I write that, okay, what is the square root of 25? I'm going to let you write it in over here. I'm going to give you the ability to do your own pencil.
Please do. Okay. You want me to write in the square root of 20?
Yeah, what's the square root of 25? Just write it in. Okay?
Yes. Is that right?
Yeah, that's correct. Correct answer, but why is that the correct answer?
Because it is, they're equal. So, yes, it's 5 times 5.
When you have a perfect square, that number has to be multiplied exactly by the same number
Right.
to come up with 25. Okay, so that's kind of the gist of square root. Let's see, what's the square root of 16? Good, fantastic. Okay, we're not going to get into much more, but the reason I wanted to review this is because we're going to be going into the Pythagorean Theorem. The Pythagorean Theorem it's a foundational formula of math that allows you to solve a lot of different types of problems. Well, it was developed by a man called Pythagoras. When do you think he was alive? Just by looking at the name, do you think he was old or
I think he was
moderate?
probably very old.
Yeah, he lived in the 6th century BC, so we're looking at about, 2,500 years. He was considered the first true mathematician. He used math as a means to understand the natural world, and he was the first to teach that the Earth was a sphere and it revolves around the sun. So cool. Smart man.
Yeah.
Okay, just a little bit of terminology. In order to be able to use the Pythagorean Theorem, it needs to be a right triangle.
Okay.
Corners of the triangle. The other angles really don't matter. I mean, the shape can vary in size, but you have to have at least one of these corners has to be a 90-degree angle.
Okay.
All right? The longest side of the right triangle, and that's what this is called when you have 90-degree angles, the right triangle. Show me the hypotenuse.
This is the hypotenuse.
And that's the longest side. Okay, these are typically called legs. And in the formula, the legs are either labeled A or B or A. It doesn't really matter, but the hypotenuse will always be labeled C. So you set this up as a formula, as an equation to be solved by taking the data that's given, putting it into the equation, and then solving for it. Okay?
Okay.
So again, what's the terminology? This type of a triangle is called a what type of triangle?
It's a right angle triangle.
Yeah, right angle triangle, or right triangle, good. What is this?
This is a hypotenuse.
Good. This right here?
These?
Yeah.
The legs?
Yeah, you have two different legs, either A or B. Okay? And then the hypotenuse C.
Okay.
Okay?
Perfect.
Do you want to try and solve a problem?
Yes, I would love to.
Okay. Let's go to, there's a number of different problems that we could use. But you know what? I am not going to do this latter problem. a right triangle. Okay?
Okay.
Good enough. I'm going to draw in a right triangle. Whoa. Okay, and we know it's a right triangle because this is the 90-degree angle here. Okay, I'm going to say that this is feet, and this over here will be, it's going to be about 18 feet. But we don't know, this could be side A, this could be side B, and this will be side C, but we don't know what that is, do we?
No.
Okay, how would we solve this problem, Rachel? How would we find the distance of this side?
A squared plus B squared equals C squared.
Okay, you want to write that formula up here for me real
Yeah.
quick? And we'll just use that as a guideline.
Ooh.
It looks good. Better than mine. All right. Have to out, and when you see this equal, you know that you're dealing with an equation. So we can solve the equation if we know two of the sides. We can solve the third side. So let's go ahead and put some data in.
Perfect. Do you want me
Let's put
to
in A first.
Do you want me to do it?
Yeah, if you would, just go ahead and write it in.
No.
That's okay. I know what you mean.
Right. Thank you.
Right here, like we are, okay, where with the powers, and we need the exponents. So let's solve this.
Okay.
What is 110 squared?
100.
Great, so good. I'll let you write the next one. Do you have your calculator with you?
I do.
Okay, what is that? And go ahead and finish the equation.
Would this be C squared or just C?
It's going to be C squared.
Okay.
We don't know what C is, right? And that's
Right.
what we're trying to find out. Trying to find out C is the distance, not C squared, but C. So let's continue to solve this equation. What will we do next?
We would add these two together.
Okay, very good. So go ahead and do that and write it out. Okay. Now, here's kind of the critical part of this solving this equation to find the length of side C. We're looking to find C, not C squared. So we need to get rid of that squared symbol. So what should we do? And just to give you a little hint, I'll just pop that in over there.
We should take the square root of both sides.
Very good. Why don't you go ahead and write that in? And the reason we do that is to cancel out. This squared is the opposite of the square root. So if we take the square root, we can cancel that out. This just becomes c, which we're looking for, correct?
Correct.
So I'm gonna rewrite this quickly. 4, 24 equals c, not c squared. So we're almost completed solving this. Do you have your calculator? Do you know what the square root of 424 is? It might not be a perfect square.
It is 20.6.
Okay, and go ahead and use your unit of measure.
Feet.
Okay, good. I'll let you finish it. Okay.
Well, I guess. Okay.
Yeah, equals c. Very good. So 20.6 feet. Now, just by looking at it, does that seem to make sense?
Yes.
Because the hypotenuse is always going to be the longest side of the right triangle. And if this is 18 and this is 10, that looks about correct, almost 21 feet from this point to that point. Does that make sense?
Yes, it definitely makes sense.
Okay. Well, let's do another problem. Let's work on the ladder problem. How high is the window? Basically saying how.
Sorry, could you repeat that?
Two in here?
Yes. It cut out.
Okay, go ahead and read that, Rachel.
Okay. A ladder leans against a second-story window of a house. If a ladder is 25 meters long and the base of the ladder is 7 meters from the house, how high is the window?
Could you use the Pythagorean Theorem to solve this?
Yes.
How so?
Well, right here, from the window down, and then...
Sorry?
No, you're fine. It's a right angle here, so we can use that on the right, as a right triangle.
Okay. All right. I'm going to have you put that on a whiteboard, if you would.
Okay.
Go ahead and draw that out for me. Okay, so I'm going to stop right there. Let me just draw in a little bit more.
Okay.
Okay, make this the house. Okay. So here is the window. And the ladder is leaning up against that. Okay? Go ahead and put the numbers in using, write the formula.
I'll label my sides, and then I'll write the formula up here.
Okay, good.
And then I'm going to input the numbers. So the ladder was 25 meters. And this is the ladder. And the distance.
That's a long ladder.
Oh!
Sorry.
The distance right here is 7 meters. So we don't have A, but we do have C and B. The hypotenuse and one of the legs. Should I write the problem out?
Yeah, go ahead and write it out. Okay, fantastic. What's going to happen next?
We subtract 7 from 25.
No,
No?
not yet. Remember, we have 7 squared.
Oh, yes, that's right.
So rewrite the equation, more simplified. Because right now we have powers. We have
Right.
7 squared and 25 squared. So let's make them actual numbers.
Okay, so we have to take the square root then?
No. What we're going to do, I'll kind of continue writing this out.
Okay, that sounds good.
Okay, what is
Oh, we have
7
to
the
solve
second
it.
power?
Yes. So 7 times 7. 49.
Mhm. Very good.
Forgot about that step.
Okay.
And then this is 625. And now we subtract.
It's not enough we.
Could you repeat what you said? It cut out.
All for A, and what we want to do is just have A, so we want to get rid of 49.
Right.
Like you said, you already said it, we're going to subtract 49 from this side, but what do we have to do on the other side of the equation to keep it balanced?
Also subtract 49.
Very good. So this will cancel out, and go ahead and rewrite this equation more simplified. Okay.
Perfect. Do you want me to finish it?
Yeah. What do we have to do now? What's left? Are we done with this problem? Is this 576 meters?
No.
No, because we have A squared, right?
Right. So we have to take the square root of both sides. Do you want me to do that?
And remember, we're going to take the square root of A squared to cancel that out.
Right.
Because the opposite of this squared is the square root, okay?
And the square root of 576 is going to be 24.
Okay? Use your unit of measure. Okay?
meters. So this is 24 meters.
Probably didn't draw out exactly to scale, but does that look like it could be correct?
Yes.
Yes, and that is the correct answer.
Awesome. Sorry, could you repeat that?
How do you feel? Do you feel like you've mastered this, or would you like to do another problem?
Yeah, I feel really good about it, but you know,
Okay.
we could always do another problem, or I feel pretty confident.
Live another lesson tomorrow.
Okay, that sounds great.
All right, Rachel. Have a good night.
Thank you, Professor Bell.
Talk to you later.
Okay, bye-bye.
Bye.
So what did you think of the lesson? Was it informative? Did it really work well with the student? I think it did. I think you'll find that our virtual classroom is the best. And one of the things that you need to make it work well is to have good teaching tutors to work with the students that need to be interactive. You need to be engaging the students with the lessons and having that one-on-one dialogue that's so important. So I hope you enjoyed the lesson. I hope if you're a teacher or a student educator that is going to become a teacher, that you'll consider becoming a tutor for 8 of the 3rd tutors. So thanks for watching, and we'll see you again soon.